let's go ahead and get started. We have a couple of our attendees. We'll see more trickling in, I'm sure. Thank you for joining us. I am Tom Crow, the community manager here at InfluxDB, and we're excited to have you for our third office hours. We kicked this off a couple months ago. Just a few housekeeping items. If you have any questions you'd like to ask, feel free to enter them in the chat feature or on the Q&A on the top in your Zoom box. Feel free to ask questions at any time. If you would like to ask a question with video, let us know, and we will go ahead and give you access to talk on the video as well, or you can just type it in. With that, does everybody want to go around and introduce themselves really quickly, starting with Anais?
Sure thing. Hi, everybody. I'm Anais. I'm a developer advocate with Influx, and I hope I can help you.
I guess I'll go next. I'm David Simmons. I'm a developer advocate here at Influx, and I'm focused on IoT.
My name is Jacob, and I work on the storage team as a software engineer.
And Jacob, you've been on a few of these with us now. So Jacob's an expert. So we're going to go ahead and get started. What questions do any of you all have for us? Let me pull up. We've got a few questions already in the hopper, I know. Looks like we just lost one of our attendees. So a little bit of your background, since we are talking primarily about IoT today. David, do you mind sharing a little bit of your experience, where you come from, what got you interested in IoT, and how you're using IoT with Influx, how that was a fit for you?
Sure. So I started doing IoT when I was back at Sun Labs. We can have a moment of silence for the demise of Sun Labs back in 2003. So I've been doing IoT for quite a while. We back then built what was the first IoT developer kit based on 32-bit processors. And I've pretty much been doing it ever since. And it's just one of those things that, you know, once I got started, I got completely hooked. I don't have a camera that I can show you my desk, but if I could, you would see that it is absolutely covered in IoT devices. I have a bunch of stuff like this, and then I have actually, made devices that fit in nice little boxes, and I'm monitoring all kinds of stuff. I have a bunch of devices that basically just do environmental monitoring in my office. So I'm monitoring things like CO2 content, temperature, humidity, pressure. I've got one stuck in a potted plant outside that monitors soil moisture. And it's one of the things that Influx is really, really good at for me is just doing the monitoring of all these devices. It's super easy to get data into and to build dashboards and things to visualize your data. So that's mostly what I use it for.
David, was there a buzzword for IoT back then? It seems like it's only like a 3 or 4 year old term in my mind.
No, we were first calling them wireless sensor networks back then, and then in about 2006, I think now the term Internet of Things actually goes back to the late 90s, it turns out. I did not know that. But in about 2006, we started calling what we were doing at Sun Labs Internet of Things, and actually put it on the website for the project that we were working on, calling it Internet of Things. So that's sort of as far back as I know of it, but I know if you go and actually research the history of the term Internet of Things, it was started by some guy back in the late, like 1999, 98, something like that.
Very cool. Well, we've got a few questions already. The first one we have that I see here is asking, can you, what kind of devices can run the TIC stack, and what are some good use cases for TIC stack and IoT?
I have run the tick stack on pretty much any device that I can get my hands on. I don't know if anybody remembers Intel had a project a few years ago called the Intel Edison, which was sort of a postage stamp sized IoT device that ran Yocto Linux. And I ran the full tick stack on that device. It wasn't, the dashboards weren't in chronograph weren't all that responsive, but the whole thing ran there. I run it all the time on Raspberry Pis and another platform called the Pine 64, which is an embedded ARM processor running a version of Linux, basically mainline Linux for ARM. And you can run it on those. I just got, although it's not even powered on and useful yet, my brand new Raspberry Pi 4 with 4 gigs of RAM, and that should be able to run the tick stack quite nicely. I have run parts of the tick stack on other things. I did get a version of Telegraph. I had to build a custom version of Telegraph and strip it down quite a bit, but I did get that running on an OpenWRT router at one point so that I could use the router actually as a collection point.
What's your plan for the Raspberry Pi 4?
Right now, it's just to get InfluxDB up and running on it and see how it performs. To be honest, I have a drawer full of Raspberry Pis. I probably have a half a dozen of them, and I just tend to not find a whole lot of use for them. I mostly want to run stuff on the smallest processor I can find, to the smallest device I can find, and then run Influx, the stack somewhere else. So, I mean, if anybody's interested, I can show you some of the dashboards that I've built for all of these devices, and I can actually go through what I believe is some award-winningly horrendous Flux code for a Flux query.
If you're up for it, I'd love to see a dashboard. I don't.
Sure.
I want to check those.
Yeah. I can.
So Raspberry Pi is too beefy for your style.
Yeah, it tends to be. I'm mostly running stuff on like the ESP32 or even an ESP8266, which is a small embedded processor that runs basically Arduino.
Those are ARM platforms?
They're not actually ARM platforms. I also run some stuff on some ARM platforms for the ARM, the Cortex-M series platforms. I run some stuff on those. The ESP is of the same class as an ARM, but it's not based on ARM technology.
Okay.
So let me share my screen. Can you all see that now?
We can.
So this is actually, I've just completed this in the last 24 hours. This is a display that is actually calculating the heat index in real time. And I don't know if anybody's ever looked into what it takes to calculate the heat index. When you're watching the weather on TV, they always, at least here in the South, they say, it's 86 degrees, but it feels like 102, right? And that's the heat index. But it turns out the heat index calculation is not a trivial thing to do. It uses something called a Rothfuss regression equation. And then depending on whether the temperature or the humidity is between certain ranges, there are adjustments that you need to make for that. And then if it's below, I believe, 80 degrees Fahrenheit, then there's a simple Stedman equation that you can use. And if you look down here, let me make this larger so that you can all see this, because I'm sure it's pretty small. Is that getting more readable?
Yeah. We can see your query down there.
Okay, so this query is absolutely atrocious. And because you can't see it all, it goes on for miles. So much so that I have actually today been playing with building into Flux a heat index query so that I can do, this is my local one that I've been playing with on my laptop. And you can see that it gets the same result, but all I do is call heat index, right? I join the temperature table, I get the humidity table, the temperature table, because they come from different measurements. So I'm actually doing cross-measurement math here in Flux. And I pull those into a single table with a column for humidity and a column for temperature. And then using that, I send it off to this heat index equation that I've now built into Flux, and it gets the same answer as that. Basically, I took all of this ugly Flux here and built it into Flux so that you don't have to write it, you can just call it. And if you want to see what the raw data looks like, you'll see I have a temperature table, right? And I've got all my temperature values. Let's make this less data so it's smaller tables. So here's my temperature values, and here's my join with the temperature and the humidity. I'm not sure why they're coming. And then here's my table with the heat index values calculated.
That's pretty cool.
So,
And
so heat index takes two inputs, humidity and temperature. Is that right?
Yes.
Okay.
Yeah.
And
And
that's something you can push to as a PR into Flux.
I'm talking to the Flux group about doing exactly that. There is another one that I've been working on. You'll see up here I have raw versus compensated CO2. I'm measuring CO2 concentration, and then there's something that you need to do to adjust for temperature and pressure with gas calculations called an ideal gas law calculation. And you'll see that I'm basically doing the same thing. I'm getting the temperature, I'm getting the CO2, and I'm getting the pressure, and those are coming from 3 different measurements. So I'm doing cross-measurement math across 3 different measurements. And then I got to join it all together, and then you'll see right here, this right here that I'm highlighting is the ideal gas law calculation.
Very cool.
So I'm doing that, and I'm actually looking at putting that into Flux as well, so that you can just hand the, create a table with whatever gas you're trying to compensate the concentration for, the temperature and the pressure, and then a single call to ideal gas law will get you back a table with the ideal gas law calculated for you.
To do this kind of join work in InfluxQL, would you be able to do it if your fields were all within one measurement?
If your fields are all in one measurement, yes, you could do it. But if they are in separate measurements, then no, you cannot. And one of the things that I've always done with my IoT data is different devices put their data into different measurements. And I don't know why I do that. I just started doing that early on, and it has carried over. So actually back when I was using InfluxQL, this was stuff that I absolutely could not do without a whole bunch of shenanigans of writing some capacitor code or continuous queries for each measurement to write all that data into a common measurement and then do it there, or rewriting all the code for my devices to keep it on the same, to put it all in the same measurement. This is just a lot easier, and being able to do math across measurements has opened up a whole lot of stuff that I can do now that I couldn't do before. That's super useful.
Nice. So that shows off how to use InfluxDB for your IoT devices, plus shows how cool Flux is, the capabilities you have with Flux. That's awesome.
Yeah.
One of
And how extensible it is, because you can actually do this yourself. Put a query, that if it's a really complicated query, you can put it into Flux yourself, and then of course you have to build your own version of Influx to use your version of Flux, but it's pretty extensible that way.
That's awesome. One of our community members, Siam, asked, if you have any containerized workflows you've run on devices?
I typically don't, because first of all, the devices that I use are too small to run containers on. They're very small embedded devices that run a single application, and there's no possibility of running containers on them. On some of the edge devices that I've built using things like, for a Raspberry Pi, you could certainly containerize everything and put it in separate containers on the Raspberry Pi. I tend to think that for a lot of those situations, that's kind of adding more overhead than you need, given the constrained nature of the devices. Maybe that's not so much a concern with the Raspberry Pi 4 that you can get with 4 gigs of RAM. But when in the smaller devices, you're basically just adding overhead to everything that you're doing by containerizing it on a small device.
Rick Spencer just asked a question about setting up an RPI to talk to Influx 2.0 Cloud. Is that something you can do? And do you know how you'd recommend setting that up?
To setting up a Raspberry Pi to talk to Influx 2 Cloud?
Yes.
Yeah, that's pretty straightforward, actually. The easiest.
Hold on one second, David. Richard's asking to talk, so I think he's got some more questions. So there we go. Rick, you can talk now.
Oh, okay, thank you. My specific question is how to set up the comp file for Telegraph. Like, I wasn't able to find like a canonical example, so I just want to I have like an Arduino with a bunch of sensors. I'm talking to the Raspberry Pi over serial. Then I want to talk to Influx Cloud, but I want to use Telegraph for that. I can't find a simple comp file anywhere to set up Telegraph to talk to
Let me real quick look at one of my config files and see if I can find that for you.
Yeah, we don't have to like block everyone on this. Like, if you just want to put it on GitHub or something like that, like when you have time or whatever, that's fine.
Doesn't Telegraph have a flag, telegraph-config? Let me try it.
It does. I'm just like looking for an example comp file that just says put the IP address for your cloud here. You know what I mean? There's like documentation and everything, but there's just not I could not find I'm sure there is somewhere that I can find just a super crisp example. It seems like I should just be able to copy a file.
You're looking for an example config to write into Cloud 2.0.
Yes.
Okay. Yeah, that's, let me see. I'm just looking to see if I have that enabled in my config file, and I could just point it to you.
Thanks. Sorry, I didn't mean to hijack the whole call.
No, that's okay.
And no, that's why we're here. This is exactly why we're here.
This is what the call's for.
Like, this is like a super fun, super fast scenario. Like, you can sign up to the cloud service in like 2 minutes, then just like download Telegraph, drop this comp file on there. And
yes, and so there is a section in your telegraph.conf file called outputs.influxdb_v2.
Right.
And then there's a spot for URLs. And if you put the URL for your InfluxDB to cloud account in as that URL, And then there's two choices you have, because in InfluxDB 2, everything is token based. So every database access requires you to send a token along with it.
Right.
So you can either put in your InfluxDB, your telegraph.conf file, you can put token equals and that token string, or you can, in the shell that you're going to start Telegraph from, you can export influx_token equals with the token string, and then start.
Set an environment variable to the token.
Yeah, and so it will pick up the InfluxDB _token, all uppercase, from the environment. And if that's not set, then it will look for the token in the telegraph.conf file. And if that's not set, then it'll break.
Okay.
Yeah, we can add an example of configuring for cloud.
I think somebody pasted me a GitHub link.
Yeah,
Actually, what I can do right now is,
I think that has
A guess to that as well.
If I just use this, it'll just work.
Well, you'll have to fill in the URLs, the token that we're going to bucket.
I filled in the missing parts, but
Yeah.
this will just work.
Yeah. Yeah, and if you've got do you have an open source InfluxDB v2 running somewhere that you can test with? API is the same, is why I'm asking.
I just posted in the answer to the question, the section from my telegraph.conf minus the token equals line, because I put my token in my
as an environment variable.
No, I actually put it. On my local machine, I put it in the configuration file. On the server that I run, I put it in the environment variable.
I see. Okay. I just want to use cloud though, because the free tiers.
Right. So you just change the HTTP to HTTPS : and then the
whatever
your cloud instance, and it should begin writing to that just fine.
Perfect. Okay. Thank you so much. This is perfect.
That's what we're here for.
And David, Joel asked, are those JWT tokens?
I don't know if they're JWT tokens or not. I don't know where the tokens come from. I don't know quite how they're generated. I've never been, frankly, I've never been that interested to look.
Gotcha. We had someone ask anonymously, they were answering this live. Are there any suggestions for how one can avoid embedding username passwords in the Telegraph config file?
For InfluxDB 1.x line, I don't think there is a way without putting them in the config file. I could be wrong on that.
Well, the way that you might do it in a production environment is with environment variables. You can provide environment variables or set environment variables in a lot of different frameworks without exposing them anywhere else. And so then your config file doesn't have to change when those credentials change too. Like with Kubernetes, you would use secrets.
Wouldn't it show up in the PS output?
Not if it's from an environment variable, no. It shouldn't.
Okay, thanks. Very cool. All right. We have more questions right now. How can I write data to InfluxDB from my Arduino project?
Oh, that's an easy one. Because I do this, that's basically where all of this data on these dashboards comes from. With very few exceptions, it all comes from various Arduino devices. Oh, looks like my soil moisture sensor is dead. I'll have to fix that. So let me show you how to do that.
I like this hands-on approach to our office hours that you're doing. Thank you, David. This is fun.
Sure, I love doing this stuff. This is what I would like to spend my whole day doing every day if I could. And sometimes I do, so just don't tell anybody.
And just so you know, Anais shared with us in the chat, if you want an article on that, she shared an article on writing data from Arduino to InfluxDB version 2.
Yeah, I think I wrote a blog post about that at one point.
You did. It's your article. So thank you, Anais.
Thanks, David, for writing it.
Well, thanks for finding that and posting it in real time.
You're posting stuff pretty quickly, Anais. You're on it.
She is always on it.
We're going to bring Anais back on in the future for a data science edition of Community Office Hours.
So I'm going to, I just have to do a couple of things before I bring this over so you can see it. And, so this is, I'm going to have to make that larger, aren't I?
Yes, that's pretty tiny.
Is that better?
There we go.
Okay. So this is, you'll notice it's called Fig Stick, and that's the sensor that's currently dead, the soil moisture sensor. But I'm sure what happened is that since it's outside and on solar power, the sensor came loose. But you can see that I'm defining an InfluxDB host. And actually I'm defining, I'm creating two InfluxDB objects, one for a remote host, and this one is actually a local host, right? And then in my setup, I'm telling those Influx instances a couple of things: which bucket, which version. So I'm using version 2 because I'm writing to a 2.0 version, and what port. And, oh, well, now you can see my token. And I do that for both of those, right? So now the Influx object is set up with its telling it what bucket to write to, what organization to write to, what port, and the token. And so when I go down here, you'll see I read the power off the battery pin. I'm getting the Wi-Fi signal strength because I like to keep track of that so I know whether the sensor's dead or the Wi-Fi's dead. And then I just create a row, an Influx data row, and tell it, add some tags to it, and add some values. And this one, I think I turned off batch mode, but so I prepare the row and then I write the row. The other thing that I can do, and I do in a lot of these, is I set a batch count. And so it's much more efficient to write batches of data than it is single rows, because there's all the overhead involved in setting up the HTTP connection and writing the data and then tearing it all down. So it's much more efficient. I usually set my batches to be somewhere between 5 and 10 rows. So I'll collect once a second until I've got 5 or 10 rows of data. And then when I've got the batch size full, I'll write the whole batch out to the database and start over again. And that's really all there is to it. And this library is called, oddly enough, InfluxDB. And it's part of the, you can find it in the in the Arduino library set. And I actually wrote the patch to make it available for InfluxDB 2. If you're not using InfluxDB 2, you're just using InfluxDB 1, then you don't have to set things like the bucket and the org and the token. And there's other stuff you use to prepare your data, but it's the same of create a row and then write the row. So it's really easy to write from Arduino to InfluxDB.
Garov is asking, how do we write data into InfluxDB Cloud from Gatling Frontline? Are you familiar with Gatling Frontline?
I am not.
Garov, if you'll email me, Tom, T-H-O-M, at InfluxDB or InfluxData.com, I will look into that and get you an answer, okay? You've answered this, so I'm gonna, but it was asked, so I'm gonna go ahead and revisit this topic. Can InfluxDB version 2 be used for IoT devices? Yes. As you can see, the everything that David is showing right now is done in InfluxDB 2.0. So.
Right, and I'm actually in the process right now of writing an InfluxDB2 library for Mbed OS as well. I hope to have that done in not too distant future.
Anais also posted in the chat, if you want to look at that, Garov, she posted a link to Gatling's docs on real-time monitoring. Let us know if that helps. We've got one more question unless somebody asks any more. And the last one we have is, how can I get data from the Things network into InfluxDB without rewriting everything?
Oh, that's super simple. I actually had to do this a couple of years ago at a workshop I was teaching, and they were doing everything in the Things network. And it turns out that the Things network collects everything and makes it available on an MQTT broker. And so all you need to do is configure a couple of lines in your telegraph.conf file to read from that MQTT broker. You need to give it the broker name and the topic name and your credentials for that broker, and it will begin sucking immense amounts of data out of the Things network. And Anais is probably right now looking up the blog post I wrote on that to post it in the chat, because I wrote a blog post about that about 1.5 years ago.
We'll get that linked as well on YouTube. This is all going to be on YouTube, so all these links will be there as well. If we don't have any more questions, I want to thank David, Anais, Gunnar, and Jacob for joining us today. Oh, actually, we got one more. What are the major challenges when someone gets started with IoT devices, Arduinos, or Raspberry Pis?
I'd say probably one of the main challenges is just, especially for things, not so much for Raspberry Pi, but for Arduino and other embedded devices, is just getting used to writing stuff for that embedded device and using either the Arduino script or C or C++ to write stuff, and you have to be hyper aware of the amount of storage that you have and the amount of memory that you have on the device. These, devices like, this ESP32 has very little in the way of RAM and storage space. Like, we're talking, kilobytes, not megabytes. And so you've got to be aware of how much space is available and how much space you're using so that you can fit everything in.
Perfect. Like we said, all of this is going to be on YouTube. We'll have links to everything. If you have any additional questions, you can reach out to David. David, do you want to drop your Twitter here for everybody?
Sure. Oh, I sent that just to the panelists. Hold on. My Twitter is David GS IoT. And I'd love to have you as a follower. And I post a lot of IoT related stuff, occasionally about my dog, and I sometimes rant about other stuff. So there's just a little bit you'll have to filter out.
Awesome. Thank you everyone for joining us. We'll be back again 3rd Wednesday of next month, same bat time, same bat channel. We will see you then.
Thanks everybody.